Hello everyone, welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze a T-shaped pipe for its thermal analysis. We will start by double-clicking on Steady State Thermal. Next, we'll go to Engineering Data Sources, General Materials. I'll choose stainless steel as one of the material and I'll use aluminum alloy as the other material. Next, I'll go to Project and Update Project. Next, I'll go to Geometry and right click, Import Geometry. Next, I'll go to Model and double click. We'll first go to Geometry and click on Solid. Change the material to stainless steel. Next, I'll go to Mesh and Generate. I'll go to Steady State Thermal, right click and insert temperature on the inner surfaces. So you can see here, this is the top one and this is the bottom one. I'll press Ctrl and select both, apply. I'll give this temperature as say 55 degrees Celsius. Next, right click, insert convection on the outer two surfaces. I'll give the value of film coefficient as 32 and ambient temperature is 25 degrees Celsius. Also, I will induce radiation on these surfaces. Apply. I'll give emissivity as 0.4 and ambient temperature of 25 degrees Celsius. Then I'll go to solution, right click and insert thermal temperature. Also I'll right click and insert thermal total heat flux. If you want, you can insert directional heat flux along a particular direction. Say along z-axis if you want to see along the thickness. So you can change the orientation to z-axis, go to solution and solve. So now you can see the temperature. We'll just go to edges and click no wireframe such that the colors are clearly visible. Also, we'll go to contours and select smooth contours. So you can see now maximum temperature is 55 inside and at this zone over here, at this bend, you can see it is 54.719 degrees Celsius. Next, we'll go to total heat flux. We'll click on max min so that we can see where the value is maximum. So you can see where the color is red, it is 1356.9 watt per meter square, and where it is blue, it is 433.79 watt per meter square. If you want, you can animate and check this result. Now I'll click on max min such that I can remove those icons. I'll click on directional heat flux. So now you can see very clearly that along the z-axis, which is this one, how your heat transfer is taking place. This is your heat flux. So in this zone, it is red, which means it is 1115 watt per meter square. And here it is blue, so it is minus 1162.4 watt per meter square. So this is showing your directional heat flux along z-axis. If you want, you can see the directional heat flux along the x and the y-axis separately. So this is about the material stainless steel. I'll go to assignment and change this material to aluminum alloy. And let's solve once again and see the results. So now you can see the temperature change. This is not changed much. Here it is 55 and outside it is 54.972. Although we have changed the material to aluminum alloy. We'll see the total heat flux. It is 1359.8 watt per meter square wherever it is maximum. And for minimum it is 434.71 watt per meter square. We'll see the directional heat flux. Again, it is very close to stainless steel. So here you can see this 1117.5 watt per meter square, and on the other side where it is blue in color, it is minus 1165.6 watt per meter square. So that's how you can see the temperature and the total heat flux over a T-shaped pipe using two different materials. Here I have used stainless steel and aluminum alloy. You can use any other material with which your pipe is made. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.